Welcome, wonderful people. This is Mr. Ndabezita, and I want us to revise a question paper, grade 10 mathematics, paper 1. It's a question paper 2023 June examination. And in question 1, immediately we have the following. Now, in question 1, they say between which two consecutive integers lies negative the root of 69? And 2 marks are provided for this. So between which two consecutive, so meaning these numbers follows one another in that order. That's what consecutive means, one after the other in that order of whether increasing and so on. So meaning the first thing that I need to know the decimal of this number. Writing negative the root of 69 in a decimal form, going to my calculator, I think I'll say negative the root of 69, and I get negative 8.31. And if this is the answer that I get, I need to find two consecutive integers. And those two consecutive integers, this has to lie between them. Okay. So if it lies in between negative root 69, so meaning the number on the side must be smaller than this, and the number on the side must be greater than this. That's what in between would require, because if you are in between, looking at the Cartesian axis, if you are in here, the numbers that are between you, the number on the side has to be smaller than you, and the number on the side has to be greater than you. So that's the requirement. So I'm looking for two integers. One should be smaller than minus 8.3, and the other has to be bigger than minus 8.3. But they have to be consecutive. Those numbers have to be consecutive. So meaning I have to move in an increasing order of these integers. Okay. So the first thing I will do, you look at a number before your comma, and you say to yourself, what number, when I take the square root of that number, I will get minus 8. In fact, leave this negative outside. Just concentrate on the number as if it were positive, and you will say, what number, when I take the root of that number, I will get 8. And I think we all know that the root of 64 will give us 8. Right, but because this is a negative, you will have to find two integers that are negative. So you will say negative the root of 64. As a result of saying, you place your negative outside, then you say root 64, then you get negative 8. So this, it's negative 8 because we are dealing with two integers, though that must be negative because this is negative. If it were positive, we will look for two integers that are positive. Since it is negative, we're looking for two integers that are negative. Okay, so they have to be consecutive. I know the number after minus 8 is minus 9. That's what consecutive means. So what number, again, when I take the square root of that number, I should get negative 9, because negative 8 and negative 9 are consecutive numbers. So I will go again, say negative, inside of my root, what number, when I take the root of that number, I will get 9. That's 81, if I'm not mistaken. Yes. So negative root 81 equals negative 9. Now I have my two consecutive numbers. and they are integers. Now I need to find a way how to place them on my brackets here. I know that negative root of 69 has to be in between, and I need to have a number here and a number there, and I know the number to the left has to be a number that is smaller than this, so meaning this must be greater than that number. Do you see how the inequality comes into effect? And then I know the number on the side has to be a number that is bigger than this. Do you see how the inequality comes into effect? So now that I'm dealing with two negative integers, I know that negative 8 is bigger than negative 9. Right, the number on the left has to be a number that is smaller than this. And I know this number, it's negative 8.31. Which number is smaller than this between these two numbers? I know that minus 8 is bigger than this, because on a negative number line, this is your minus 8 and your minus 8.3, and I know that this number is bigger than that number. So on this side, and there is my minus 9. So minus 9 is smaller than this and this. So you are the smallest. I will place you on this side. I'll say minus root 81, and on this side I'll say minus root 64, and I know the answer for this, it's minus 9, and I know the number for this is minus 8. So meaning negative root 69 lies between minus 9 and minus 8. And if I check, is this number bigger than this? Yes. Is this number smaller than this? Of course, based on our drawings in there. So we are done with this. I'm very sorry for taking a lengthy way of explaining. It's just that I wanted everybody to understand what is happening here. Okay, now in 1.2 they say that I should show that 0.9 with a dot telling you that this is 0.999 continuing in that way. This is equals to 1. Now if this is equals to 1, the question is, how is that possible? How is it even possible that this could equals to 1? Now we're going to go to a calculator, try to place this maybe with 3 nines just for a decimality, or we will even take 4 and see exactly what answer we will get. Now if you just go to your calculator and you say what is 0.9 as a fraction, it will give you 9 over 10. So this is 0.9, but there's a dot here that tells us maybe to take just a little few more 9s. So I'm going to change this to 4 9s and see what effect it will have. 1 2 3 4, and I now get, if I say 0.9999, I will have to divide this by 10,000. This is exactly what I get for this. It gives me this. Okay, so if I want to write this as a decimal, this gives an answer of 0.999, which is the approximate whole number of 1. So 0.9 is not exactly equals to 1. It is approaching 1 but not equals to 1. But as 0.9 approaches 1, we can round off this to a whole number of 1, but the answer will never and ever be 1. So this is a rounded off number. To say that this is equals to 1, it has been rounded to a whole number. So how are we going to solve this? Okay, now Remember, I was told that 0.9 with a dot is equals to 1. Now, the first thing that I'm going to do, I'm going to say let this 0.9 to be equal to x. So everywhere where I see this 0.9, I will be writing x. That's exactly what I am saying there. Okay, let me just do this.